only difference between variance and standard deviation is the square root. The covariance is different. Correlation, covariance is different. Variance and standard deviation is different. We have used standard deviation for, we need to calculate standard deviation, we need to apply on covariance to get correlation. That is different. The very concept of standard deviation is different, right? All right. So we'll get into the most important topic, outliers. We would have heard these outliers. Where have you heard these outliers? Where have you seen, like, and then it's better to ask, where have you seen these outliers?
Skewed map on that one.
All right. And where else? In visualization, we have seen.
Box
Distribution.
plot.
In the
Yeah.
distribution part.
Yeah. In box plot, we have seen, right?
In the data distribution model.
Yeah, in data distributions, if it is skewed, we can say that there is a possibility of having outliers, but clearly we can see it in box plot. Let's take that this is a data set, whereas this one is the index 1, 2, 3, 4, 5, and so on and so forth. Minus 3003. This has been sorted out already. If the data is not sorted, you need to sort it out. Okay. And what is the minimum value in this data set?
3.
First value is minus 3000, right? Is it not minimum value? Is this not?
Minus 3000, correct.
So minus 3000 is the minimum value. What is the max value?
89,000.
89,919.
Yeah. So be interactive in this outlay is very important. Maximum value, right? The fact is we should not calculate minimum maximum value in this way. Basically, when we calculate minimum maximum value, we sort it. We basically keep the data in ascending order, and the first value is going to be the minimum value. The last value is going to be the maximum value. That is how we typically do that. But the reason why I said we should not do that is because when we try to find minimum and maximum value in a data set after sorting it, we are going to assume, we're making an assumption that it does not contain any outliers. Whereas in this case, it may or may not have outliers. It may have outliers, right? So the question is, how do you find out outliers and exclude it so that you're going to find out the actual minimum and maximum value? Both in terms of finding minimum maximum value and finding outliers matters, right? It's important. Otherwise, if we include outliers, let's consider this is an outlier, and if we include outliers, the whole equation, we can't apply all the statistics. Obviously, we can't derive some right conclusions. And thereafter, we can't take right decisions if we don't have right conclusions, right? Okay, let's calculate this outliers. We have data set. So we need to get I and J. The reason for that is we need to find Q1, Q2, and Q3. 25th Q1 is otherwise called as 25th percentile. Q2 is 50th percentile, and Q3 is 75th percentile. So where have you seen? Where have you heard these percentiles last time?
Describe when we are using the
exactly in df.describe. We have seen 25%. Actually, I told you that it is not percentage. It is difficult to write as percentage. So it's actually 20th percentile, 50th percentile, 70th percentile. And I told you then that I have not explained. I will explain this percentiles later, right? Now we are going to calculate Q1, Q2, Q3. That is 20th percentile, 50th percentile, 70th percentile. So Q1 formula is I plus J minus 1 into 0.25. Why do we have this 0.25? It is because 20th percentile. Let's take we can even calculate 20th percentile also. Then in that case, it's going to 0.20. But what we need here is Q1 and Q1, Q2, Q3. Okay. So any questions on this part? This is the formula to calculate Q1. Now, what is I? I is the first index value. Index value is 1, whereas the J is the maximum index value, that is 2. We have only 12 rows. So it's 1 plus 12 minus 1 into 0.25. So what after simplifying is 1 plus 12 minus 1 is 11. 11 multiplied by 0.25 is 2.75. This part is 2.75. 1 plus 2.75 is 3.75. Any questions on this part?
Sir, how you get that value of I and Q? That is cool.
Again, you're going back to the same thing. So the first index value is I. Last index value is J. These are the actual values.
So
And
what
what
if
is
the
6
index is 0? Do we have to use that one itself? Or
in statistics, we don't use 0. In Python, we use 0 in because programmatic program I mean it's more programmatic in nature. So the way we store data, that is how it got its index 0. And statistics, there is no such thing as 0 index.
I and J are
Oh.
index values are direct that index numbers. It's an index number, right?
Index number, I and J are index numbers. Index values are this, right?
Yeah.
Any other questions? This part is clear, right? So we got 3.75. So
Yes.
3.75 is not the actual value, it's actually index. We need to find the actual value. How do you find that? So we don't have in any index called 3.75. We have 3 and we have 4. The 3.75 falls in between 3 and 4, right? But we
Yes.
don't have 3.75 precisely. So the way we need to calculate 3.75 is, we know 3. What is 3? 10.
and
Let's take 3.75. 3 plus 0.75. What is 3 is 10 plus we need to calculate 0.75. 0.75 is between this two. So if it is between these two, so the way we need to calculate is 14 minus 10 multiplied by 0.75. That is 0.75 portion of this difference. Got it? So 14 minus 10 multiplied by what is, we have 0.75, right? That is index. So what is the value now? 10 plus 4 multiplied by 0.75. That is 3, right? 4 multiplied by 0.75 is 3. So 10
3.
plus 3 is 13. So 13 is the Q1 is 13. The same way we can calculate for other values too. The only difference here is for Q2 it is 0.5 and Q3 is 0.75. Okay. How do we calculate 6.5? Sirisha? 6.5. 6.5 means here. Yeah. How do we calculate 6.5?
It will be in between 6 and 7. So 6
Yeah.
plus 0.5. So how we have to calculate is 20.
Okay.
29 minus 22
Okay.
into 0.5.
0.5. So we get 6.5. Do we get 6.5 by doing this? 7 multiplied by 0.5. So actually what? 3.5. So is that what you mean? So how do we calculate here?
Now again we have to add that value to 22.
Which value? Which value? Yeah, 6.5 I have written, we can write like 6 plus 0.5.
Yeah.
6 is 22 plus. So 22 plus
3.5.
3.5 is actually 25.5. That is Q2. Okay. So you can see 25.5.
Yeah.
The same way you need to someone like Naren, 9.25.
it's 32 plus 36.
32.
32 plus
9.25.
9 point. Sorry. 49. I mean 36 plus
36 plus.
49.
Okay. 49 minus.
36.
Okay.
By into 1 by 4.
Yeah, 1 by 4. So
Yeah,
0.25. 0.25.
Yeah.
36 plus 49 minus 36 what?
30.
13.25. So
49.
So
49
actually,
divided by 1 by 4.
49? No need. So this is actually 49 is 36. 13. 13 multiple
Just
0.2.
odd must yeah, 1 by
Yeah,
4.
13. So it's
13
going
by
to
4.
be, I think it
2
is
point, sorry, 3 point something. Yeah,
3.25.
2, yeah.
39.25. So what we got here is Q1, Q2, Q3. This part is clear, right? We
Yeah.
know how to calculate Q1, Q2, Q3 now. These are essential to move further. So we need a few other values here. We need IQR, maxima, minima. And how do you find IQR in the case of visualization? What is IQR? Interquartile range. In box plot, I told you that the whole height of the box is IQR. Do you remember it? If we have something like this, this is Q2. Q2 can be anywhere in between. This is Q3. This is Q1. This is minimum value. This is maximum value. Anything that is above maximum value is going to be outliers. Anything that is below minimum value is going to be outliers. IQR is nothing but this whole range. How do you find this range? Q3 minus Q1. So IQR nothing but Q3 minus Q1. What is Q3? 39.25. What is Q1? 13. So 13 minus 25. 39.25 minus 13 is 26.25. Any questions?
No, sir.
Okay, the next one is we got IQR. We are slowly moving towards finding outlier. That's the final objective. Of course, we get minimum and maximum Q1, Q2 is various other values too in between. Now we need to calculate minima and maxima. And the minimum and it's not minimum value and maximum value. There is something called minima and maxima. I'll explain what this minima and maxima is all about. So minima, the formula is Q1 minus 1.5 into IQR. Whereas maxima, it is Q3 plus 1.5 into IQR. That's the formula. What does this mean? So in this case, it's Q3, right? Q3 plus 1.5 into this distance. Got it? And Q1, actually, what is this minima? Q1 minus 1.5 into IQR. This 1.5 into 1.5 times of IQR.
So what is that 1.5? I mean,
So
is
1.5 is actually they have taken 1.5 of 1.5 times of IQR. Actually, in practical sense, it can even take 1.2, 1.3, 1.4, 1.8, 1.9. But actually, in statistics, they came up with this 1.5.
So that is a standard value, whatever may be
Yeah, we can change it if we want, but that is standard value.
So why are we considering that 1.5 times of IQR?
Yeah, that is 150% of the IQR, this whole height. So we are trying to find out this part to find the minimum value and the maximum value. So this distance, we need to calculate it. So they consider this 1.5 times of Q3 plus 1.5 times. We are going to get the maximum value. Q1 minus 1.5 into 1.5 into IQR. So we get the minimum value. Why this
Okay.
1.5 can be any other value too, but after having several experiments, that is how they came up with. But in reality, we can even change that value. We can consider 1.5 times of IQR, 1.25 times of IQR, whatever. Okay, after we know what is Q1. We know what is 1.5 is anyway constant. IQR we know 26.25. So Q1 is 13, right? 13 minus 1.5 into IQR. So what is IQR? 26.25. So minus 26.375 is the minima value, not minimum. In the same way, we need to calculate maxima. Q3 plus 1.5 into IQR. What is Q3? 39.25. 39.25 plus 1.5 into IQR. So what is that Q3? 39.25 plus 1.5 into IQR. What is IQR? 26.25. So what we got here, 78.625. Do we have, these are minima and maxima. So do we have any values like this in this series? Minus 26.375 and 78.625.
No.
Now, this is going to give an approximate minimum value and an approximate maximum value. It's not going to give us the precise value. Now the question is, how do we calculate the minimum value and maximum value? Okay, then that is the next step. The next step is, in order to calculate the minimum value, what we need to do is greater than minimum value, the first value. Anything that is greater than this value, okay, that has to be the first value. What is the first value that you get that is greater than this value in this list?
3.
3. So greater than minus 26 points, minus 3000 is not going to consider, because minus 3000 is going to be less than this one, right? Because it's a negative sign. So
Negative.
3 is going to be the minimum value. So this is not the minimum value. So we have to erase that. Same way, it erases the maximum value. So now maximum value is anything that is less than this value, first value, from bottom. What is less than this value and the first value from bottom? I mean descending order.
49.
49, 78.625, less than that.
Oh, sorry, 70.
So this is going to be the maximum value. Okay. And anything that is above the minimum value, I mean to say less than minimum value, is any, it can be one or more than one value. So anything that is less than this value is going to be considered as outlier. Anything that is above maximum value going to be considered as outlier. I think the same box plot is the same case, right? Anything that is above this line, we have started seeing dots. Those are outliers. Anything that is below this line, I don't know whether we have any data as such, but anything that is below this line, anything that is below this line, these are outliers. So any questions on outliers and how to find outliers?
No, sir.
Sirisha?
No, sir, no questions. Mhm.
Bharat has not joined, I think. All right, the next one is probability. Let's take that you have taken two coins, so a coin, one coin, that you tossed a coin. There are only two possibilities we can get. One is head, another one is tail. There is no other option, right? Do we get any other option other than that? Unless, is there any other case like unless? Kind
No,
of.
only two possible.
Only two possibilities, head or tail. And obviously, let's take that. We need to find out, we need to record total number of possibilities after tossing a coin. So total number of possibilities are head and tail, which means two possibilities. So then we need to find out for each event. In this case, event is head or tail. So possibility of getting head is, if we toss a coin, what is the possibility of getting head? There is only one possibility, right? Out of these two, there's only one possibility that you get head. And there's only one possibility that we get tail, because there is only one head on in a coin, right? And there is only one tail in a coin, on a coin. Now we need to find the probabilities. The way we can find out the probability is, suppose if you want to find out the probability of getting head, we need to find out the possibility of getting head first and total number of possibilities. And probability is quite easy. It's 1 by 2. Possibility of getting that particular event by total number of possibilities. 1 by 2 is 0.5. So it means there is a 50% chance that I may get a head if I toss a coin. The same case for tail also. 1 by 2, that is 0.5. There is a 50% chance that I may get a tail on like when I toss a coin. Any questions on finding out the probability? If you go with this approach, you can easily understand probability. But if you don't consider this, if you directly jump to this one, you may not understand why we need probability. Okay,
If you have time, could you just give us one more example? It's a simple non-example, right? Like any.
known example.
I mean, in our studies also we will be knowing, right? Possibility of tossing a coin is either one or two. I mean,
Right.
with respect to data, this course, what will be the other practical example suitable?
There are algorithms wherein it depends on condition probability. The whole idea of this probability, like why we are discussing is because there's something called condition probability, wherein there are certain algorithms like Navier-Bayes theorem depends on.
Okay.
But without understanding, like we are going to go step by step.
Okay.
So next one is, let's take that if you have tossed 2 coins. So what are the total number of possibilities then? In one coin, it's 2. If it is 2 coins,
4.
4. So possibility of each event, in this case, each event in the sense, we toss 2 coins at the same time. Then it's going to be possible of getting head-head is a one event, tail-tail is one event, another event, HT is one other event, TH is another event. Right? So we need to record for possibility of getting each event and total number of possibilities. If you want to find the probability of this event, that is probability of getting head-head, it is 1 by 4. That is 0.25. So there is 25% chance that if you toss 2 coins, you may get head and head in both the coins. Right?
Yeah.
The same way we need to find out the possibility of getting, we know the possibility of getting TT, HT and TH, the same process, right? 1 by 4. 1 by 4 and 1 by 4. So 25% chance that we may get head head or tail tail or head tail or tail head. Is this clear?
Yeah.
And let's take that if we toss 3 coins at a time, it is difficult to keep on extending, isn't it? So in order to solve that problem, we need to have these formulas. Probability of A and B in the sense, both the events occur at the same time. Okay, A or B means either this or that, head or tail. Whereas in this case, one coin has head and another coin has another head. So head and head. You get the point? This is head or tail if you toss a coin. Whereas in this case, it is head and head. If you toss 2 coins, in one coin, head, other coin head. So in such case, you need to consider as A and B and case, whereas R is either this or that kind of situation. So if it is if you want to find out the probability of getting A and B, it is probability of A multiplied probability of B. And the same way, probability.
Sir, probability of A and B is for 2 coins and probability of A or B is for the single coin.
Leave about 2 coins or 3 coins. We are going to focus only on formulas.
So A and B is H and H. A or B is HT also we can use that for or what purpose?
Yeah, of course we can use it. So don't get into this one. I gave you an example. But so we will get into that back again. So A and B is when both the events occur at the same time, whereas this one is either this or that event kind of situation. So in the case of probability of getting A and B is probability of A into probability of B, whereas in this case probability of A or B, if we get it, the formula is probability of A plus probability of B. Now we can take this help, we can take these formulas and extend this from 2 coins to 3 coins. How do we do that? So basically, like if it is 3 coins, what are the possibilities of getting? What are all the possible events first? Total number of possibilities. Total number of
6 maybe.
Total number of possibilities. What all things we need to do? So we need to find out the possibility of each event. What are those events? You said total number of possibilities are what? 6. How do you get this 6?
HHH, TTT, then HTT, like
HHH,
TTT,
TTT,
HTT,
T, H,
HTH.
HH.
HTH,
THH.
THH, TTH.
Yeah.
What else?
HTH. हो गया वो.
THT.
It is done, I think 6.
Oh.
THT,
THT has not done.
THT, yeah, right. THT. We don't have THT. Any other?
THH.
Did we miss anything? HHH, TTT, it's fine. HTT,
HHT.
HHT, yeah, HHT is missing. Total, how many possibilities?
8.
8. Basically, the way you need to look at it like 2 square, 2 cube kind of. Okay, anyway, so total number of possibilities are not 6, 8, in fact. All right, possibility of each event in sense, each event HHH, TTT kind of. So HHH, how many times, what are the possibility of getting this event? Each event
1
obviously
by
it's going
8.
to,
1
yeah,
by 8.
1 by 8.
no, that is probability.
Okay.
So first of all, we need to find the possibility.
One
How
time.
many such events can happen?
1.
Again,
One time.
so for almost everything is 1, right? So
Yeah.
this total number of possibilities, I'm going to erase it. I have written the total number of possibilities. Now, what is the form? Like obviously, it's going to be 1 by 8, right? Probability.
Correct.
Probability of 1 by 8 means what? 0.125.
1 to 5. Yeah.
Instead of calculating like this, so we already know what is the formula. HHH is nothing but what? Probability of H and H and H. So we are basically it is simultaneously happening. So what is the formula for this? Probability of H multiplied probability of H multiplied by probability of H, right? What is the formula for A and B? It is A, probability of A multiplied by probability of B. Isn't it? Remember the formula?
Yeah. Multiples of.
So now what is the probability of H for a single coin? It is probability of H is 0.5. Probability of tail is again 0.5. We can use that one, right? 0.5,
Into
0.5, 0.5. What is 0.125? So it matches with this value. With the help of this formula, it doesn't matter how many coins now. And let's take another coin, 4 coins. Okay. Then another 0.5. And what is
Shouldn't be using here 1.25 for the multiplication?
should we use? 1.25 what?
For 1.25, sorry, 0.125 into like that, or 0.5.
0.5 into 0.5 is 0.25. 0.25 into 0.5 is
No, for
0.1.
the 3 coins, right? 3 coins
Yeah, for 3
probability.
coins. Yeah.
We should multiply 0.125 or 0.5.
Yeah, you can multiply 0.12, 0.5, right? Then it's going to be for 4 coins.
Oh, you're doing like that. Okay.
So I'm trying to extend it.
Yeah.
Then it's going to be what? So half of 0.125, right? That's the whole thing. 625. Is it right? No. 0.625. Because it's half, right? 2 we can't divide 1. So it's going to be,
One. Okay.
yeah, so it's a 0.0625.
Yeah, it will be halved. Yeah.
Right? I don't know. Let's 0.0625. So we can keep on extending it rather than keep on doing it. But this idea is very important. So we need to, how do we calculate probabilities? Total number of possibilities, possibility of each event, and then probability. Don't directly jump to that. Okay. Now, tossing 3 coins, we have seen it. Now the question is, like, let's say that we have basket wherein we have 2 red balls, 3 blue balls,
Sir,
and
one
one.
Sorry
Yeah.
to interrupt. Then when we should use probability of A and B, or when we should use probability of A or B, like that?
So A or B means it's in the name in the very expression is going to tell us, right? Either this or that kind of. So in this case, probability of head or probability of what is the probability of getting head? Is 0.5. Probability of getting tail is 0.5. When I say probability of head or tail, what does that mean? So probability of head plus
Plus
probability of tail. 0.5 plus 0.5. I think Srisha is busy.
No.
I'm like Sandeep Reddy Vanga. So I'm going to definitely ask. An interviewer asked a question, he didn't listen. And thereafter he questioned him. Okay. So 0.5 plus 0.5 is 1, right? So what is what H or T, what does that mean? It means that what is the total probability, isn't it?
Yeah.
Total number probability obviously is going to be 1. So when you toss a coin, obviously you get either head or tail. So there is a 100% chance you may get head or tail. That's what this means. Let's take another one. Probability of HH or probability of HT in the case of 2 coins. What is the probability of H plus now it is probability of HT, right? Probability, what is probability of HH? Is 0.25. 0.25 plus 0.25 again. This is 0.5. There is 50% chance that if I toss 2 coins, I may get either head or head tail. What are the other possibilities? TH and TT.
Yeah.
so the total possibility is 1 if we consider all the scenarios.
Yeah. If we add up all the probabilities, it is going to be considered as 1.
1. If the single is only 0.25, if you take the 2 coins, it will be 0.5.
Yes, you should not look at it as proportion. Rather, you can say that this event, what is the percentage of getting occurred? So 0.5 means what? 50%, right? So there is 50% chance that we may get tail. There is 50% chance that we may get tail, head. There is 25% chance that we may get head. What are the other 75% chances? There are 3 other events, each 25% each. Okay.
Okay.
And 2 red, or let's take that we're extending this topic and we're going to see probability also in this case. But here I'm going to explain condition probability. So, and rather than starting with the concept, the name of the concept, it is better to start with an example. So let's take that you have a basket wherein you have 2 red balls, 3 blue balls, and 1 black ball. Total number of possibilities here? 2 plus 3 plus
3
1,
plus 1.
6.
Yeah.
1 is 6. 6.
Okay. Yeah.
Now we need to find out the possibility of getting each event. Okay, let's take that. What is the possibility of getting first ball as I have taken a ball from the basket. Okay, what is the possibility of getting red ball? Possibility of getting red ball is, first of all, we have to have total number of
2 by
possibilities.
6.
Total number of possibilities of that particular thing, 2,
No, 2.
3, and 1, right? So
Yeah.
okay, I think we directly jump to probability. So just to, first we need to sort out the possibilities. Possibility of each event is 2, 3, and 1 based on the number of balls. Now we need to calculate the probability. Probability of
2
getting
by
this one 2 by 6.
6.
2 by 6, 1 by 3 is 0.33. And the possibility, what is the possibility of getting another red ball? It can be even blue ball or whatever. What is the probability
Yeah,
of getting
already
red?
1 ball is taken.
Why? So basically, the idea is once you have taken the ball, you have kept it aside. You have not placed it back again. If you have placed the back, place it back again, then it's going to be again 2 by 6 for red ball, for another red ball. But if you don't place it back again, if you kept it aside, it's going to be 6 minus. Now the basket has only 5 balls. Now the basket has only 1 ball because we already taken 1 red ball. So basically, we are trying to find out only the probabilities right here. So we have only one. So now probability of getting red ball is 1 by 5,
1 by 5.
0.2. Any questions?
0.5.
Is this
Okay.
part is clear?
Clear.
Yeah.
All right. The next, actually, this is, we should not write like probability of getting red balls. We should not write like this. Usually what do we do is we probability of R or probability of red or probability of red ball, something like this. But we should not write like that. The reason for that is there is an event happened even before that. What is that event? Another red ball. So how do we read this? Probability of getting red ball. We are trying to find probability of getting red ball, knowing the fact that there is another event happened. What is that event? They have already taken a red ball. So we need to consider that to find out this. So, right? So only in the
So
case
normally consider already taken or it is present.
it's already been taken. So it's already been taken.
Okay.
This 0.33 is the 33% chance that they may get fast ball as red ball. When you're going to consider this one, and then we're trying to find out here. So this 0.2 is basically probability of getting red ball, knowing the fact that there is another event happened. What is that event? That we have already taken red ball.
Taken the red ball.
I need to extend it further. So we have taken 2 red balls now. So 4, here
4
red
balls
ball is
remaining.
0. If we try to calculate probability of getting red ball again, obviously it's going to be 0. 0 by anything? 0.
Yeah.
Okay, next then probability of getting blue ball. What is the probability of getting
0.75.
3
Yeah, 3
by
by 4.
3 by 4. So 3 by 4 is 0.75. But actually probability, how do we write this probability of blue ball? Probability of B RR. Can we write like probability of B RR? Probability of B, we're trying to find probability of B, knowing the fact that there are other 2 events happen, that is taking 2 red balls. Right?
Okay.
This is condition properties. Condition in the sense, this is the condition.
Okay.
Normally, we are not going to we are going to replace it back again. But in this case, we are not going to replace it, so we have to consider that. Conditional property is all about there is a condition before you find out the probability. That is what it means. Okay, so this 3 by 4 is clear, right? We have taken 1 blue ball. Now, we need to subtract 1, right? From total possibilities. And we need to subtract from blue balls also. Now, what is the probability of getting another blue ball? 2
by 3.
2 by 3. Again, 2 by 3 is 0.67. Again, how do we write this one now? Probability of B by BRR. Can we write like that?
Yeah, prior
There were
conditions.
3 events happened, right? Now this 0.67 is probability of B. It's not just probability of B. It is B knowing the fact that there are 3 other events happened. What are those events? We have taken blue ball, red ball, and red ball. So we have taken another blue ball. So it's 1. And we have overall thing obviously is going to come down. So we can keep on doing that, right? 1 by 2 and 1 by 1.
Yeah.
Obviously, the last ball is going to be if we find we don't have any other balls other than if you have already taken blue ball and red balls, then we are going to have only one black ball, ball, that is black ball. So total probability is going to be 100% chance. Okay, this is what the condition probability is all about, right? As I have written it. Any questions on condition probability?
Based on the previous condition only, we will calculate that, right?
Yeah.
That's it.
Basically, what happens is the condition is going to reduce total number of possibilities and possibility of each event. It's going to keep on reduce, right?
So in academics, we had this formula, right? NPR, something like that. So
That is
this the same way?
Yeah, NPR is basically permutations. Permutation, right? This is probability. Permutation combinations are different. Permutations are what are the possible, like let's take A, B, C, A, B, B, C, A, B, C. So that is permutations. Here we have calculated probability, right? And what are the possible events? HE, HH, HT, these are permutations. We're going to calculate the probability here. All right. The next one is, let's take that you have taken two balls. One is red ball, another one is blue ball. You have kept in a basket. Okay. So what is the probability of getting red ball? It is one red ball by
Only
total
two balls are
positive,
there, 0.5. Yeah.
0.5. And the next one is that you already taken red ball,
Considering the red ball is taken, 1.
one, right? So let's take that in the
Yeah.
first chance that you got blue ball. Probability, we are trying to find out the probability of blue ball. Then it's going to be the same case, same
1.
case is going to be repeated. How come it's one? So we have taken a basket wherein we have two balls, but in this particular case,
Yeah.
I want to find not red ball, blue. The first event is we already placed it back again in the basket. So it's a new event altogether.
Yeah. 0.5.
So this is 0.5 and this is again probability getting red ball is, it doesn't matter which order which create. It's going to be the same, right? The overall possibility thing is going to be same. So probability of red into probability of blue by red equal to probability of blue into probability of red by blue. Can we say that?
Yeah.
Yes.
So that is what this is. So condition, and if we know three of these values, it can be any three values. And if we don't know the other value, we can easily find it out. Let's say that I don't know probability of red. Then probability of red equal to probability of blue into probability of red by blue by, can we make it down? So denominator part by probability of blue by red, blue red, right? Something like this. So if we don't know what is probability of red, then you're going to come here. Okay, clear? If we don't know one value, if we know other three values, we can easily find out the other values, right? Let's take probability of blue. I don't know. What is the probability of blue, right? Then how do we find out that?
Red into blue or red divided by probability of red by red.
Red by blue, right? So we need to divide by this thing. This is nothing but Naive-Bayes theorem. So if we formulate it, it's going to be like this. Probability of B by A equal to probability of B into probability of A by B by probability of A. Probability of A by B is actually probability of A into probability of B by A by probability of B. So all the Naive-Bayes theorems or any M and B, B and B, there are algorithms wherein it depends on this Naive-Bayes theorem. This is the whole idea of Naive-Bayes theorem. Okay. Any questions on this?
So you have taken the example of two balls, right? There can be multiple balls and we
Yeah.
can do the same thing for those.
Of course, we can extend it to any number. In this case, we need to come up with a formula, so we got only two. But this can be extended to anything, any number, right? Just consider that instead of A, let's take that three events, A, B, C. Okay. In this case, what you can do is A comma B as A itself, C as another event. Yes, we got this formula. Now replace A with A comma B.
Yeah.
And then you can keep on extending it. So it's not going to stop.
It will not complicate if you take A, B as A.
Obviously, it's going to complicate. How come you can say that it's not going to
I mean, while writing.
At least we don't do it manually. That is one good part. The algorithms are going to use it. And our job is not to do it manually, but we need to understand what sort of algorithms we have, on what it based on, and how it internally is it's going to work, right?
Okay.
When I have an algorithm that is based on this one, we need to understand what is Naive-Bayes theorem. Even before that, we need to understand what is condition probability. Even before that, we need to understand what is the probability, right? All right. I think it's already 8:49. Can we stop here, or should we continue? We have few other concepts. I think we discussed central limit theorem, central tendency, confidence interval, correlation, covariance. We'll discuss it tomorrow. So we'll complete these topics tomorrow. And thereafter, mathematics we have. I will
So, in the topics from the yesterdays and today, what we need to practice, sir?
I have clearly given the notes. You need to have a good understanding of
Just
it.
go through that one theoretically, that one. That's
Yeah,
is that enough?
that's it. That's it.
Okay.
All right. Any other questions? Okay. Thanks for joining.
Yeah.